Hello, in this PixaFlux video tutorial, I'll show you how to create an Rgb Shift effect with PixaFlux. An Rgb Shift effect moves the red, green and blue channels individually to give the image a glitchy, tired look. We'll also add a blur effect and then crop the borders. Finally, I'll show you how to pack this effect to reuse it in other projects. For this project, we'll use these images downloaded from pixabay.com. Drop an image into the graph viewport. Zoom 1:1. Drag and drop a split channels node from the nodes toolbar. This node splits the RGB image to 4 value images: red, green, blue, and alpha. Add a transform node to the red channel. Set translate to 5 and 5. With the search nodes window, add a transform node to the blue channel. Set translate to -5 and -5. The green channel will be the pivot channel, so we won't translate it. Add a blur node. Connect all channels. Set the size to 6 and 6. Set boundary to clamp. The blur node blurs all the channel images with the same attributes. Add a Join Rgba node and connect channel images. The Join Rgba node takes as input monochromatic value images and joins them as an Rgba image. To test our effect, let's drop another image. Set the final node as display. Now that we have the nodes that apply the effect, let's add a few nodes to control all attributes. Add an attributes node. The attributes node allows us to have global attributes that can be used by other nodes in the graph. Add a new node attribute. Name it move. Set its type as point and set minimum to -100 and maximum to 100. The move attribute will control the translate attributes in the transform nodes. Add a point multiply node. And set point B to -1 and -1. This node will negate the move attribute. In the red channel transform node attributes panel, expose as input the translate attribute. Exposing an attribute as input allows PixaFlux to share attributes as values and modify them with graph nodes. Connect the nodes. This transform node will use the negative of the move values entered in the attributes node. In the blue channel transform node attributes panel, expose as input the translate attribute. Connect the attribute move directly as input. This transform node will use the values entered in the attributes node. You can see how the move attributes moves the red channel to the left and the blue channel to the right. Blur. In the attributes node, add a new attribute named blur and set its type to number. In the blur attributes node, expose the size attributes. Connect the blur attribute to the size inputs. Now the blur attribute controls the size attributes in the blur node. Now let's try to remove these colored borders. From the search nodes window, add a reframe node. Moving the corners of the reframe gizmo, we can remove the borders of the image. This works for other images if they have the same size. But it fails with the images of different size. We can use the move attribute to define the position and size of the reframe node. Make some room for more nodes. We'll add a few nodes that will compute the new position and size of the image. The new position will be the old position plus the move attribute. And for the new size, we'll subtract from the old size the move attribute times 2. Add an image to frame node. This node returns as output the frame of the input image. Add a frame element node. This node returns as point outputs the position and size of the frame. Add a point at node. Connect the frame position and the move attributes as inputs. Moving the mouse to a numeric output displays the values in a tooltip window. Add a point multiplied node. Connect the move attribute as point A. Set point B to 2 and 2. Add a point subtract node. Connect the size as minuend, and the multiplied move as subtrahend. Let's take a look to the values in the graph. Add a frame node. Expose the position and size attributes. And connect the values from the math nodes. In the reframe node, expose the frame attributes. The image is cropped by the frame defined by the move attribute and the math nodes. And since these operations are in nodes, they are applied when the input image changes. Now that the graph is complete, let's make it a reusable project. Add an image I/O node and connect it before the split channels node. The image I/O nodes are used by the node graph node to find inputs and outputs in the loaded project. Rename this node input. Add an image I/O node after the reframe node. Rename this node output. Now let's delete the reader nodes to remove all external references from the project. And add and connect a checker node to visualize the effects when we open this project. The attributes node is used by the node graph node to display the project attributes in the attributes panel. Let's set the default values for this project. Save the project as Rgb Shift. Let's make a new empty project. Drop an image. Add a node graph node. And load the Rgb Shift project. Notice the input and output blocks we defined with the I/O nodes, and the attributes with their default values. And as soon as we connect the image, the effect is applied. And we can control it with the move and blur attributes. This is how you can create an Rgb Shift effect and pack it as a reusable project. Thank you for watching this PixaFlux video tutorial, and please subscribe to our YouTube channel and follow us in Discord, Twitter and Instagram.